Welcome to Ekidel, where we train future civil and structural engineer. My name is Justice Umwaka. I am your instructor. Today, I'll be showing you how to prepare a bar bending schedule for your structural drawings. Okay, looking at this right now, you can know that in our previous week, we have been performing structural detailing here in Ekidel, and we have been using the template called Stonebridge Company Structural Template. You can see the template here where you have a lot of structural detailing, and this template works perfectly with a Prota Structural Design. Once you're done performing your design on Prota Structure, and once you paste all the files that was exported into this Stonebridge company template, automatically you will just see your structural work performed just like this. Okay, but for today, I'll be showing you how to detail or how to prepare a bar bending schedule. For those of you who have already bought this template, Stonebridge company template, this bar bending schedule is a new update which was just added to this Stonebridge company template. So I would say that for those of you who have already bought this template, I would say to get an update for this, I would say you should just check on the link below on my WhatsApp platform and chat me up on WhatsApp, and I'll give you this new update for this Stonebridge company template. And for those of you who has not bought this template already, I would say you should check on the link below, and then either you click on the pay stack link or you click on the seller link, which is used for the USD payment. Okay, so right now, before we start, if you have not yet subscribed to my channel Ekidel, I would say you should click on the subscribe button, because here in Ekidel we train future civil and structural engineer to like carry their career to a very reasonable height. Okay, so right now we will begin to perform our bear bending schedule right here in using Stonebridge company templates. Okay, so right now, if you have this template or if you get this template, what you do right now to perform the bar bending schedule right now, you just copy it. As you can, if you're a follower of Ekidel, you know that when you're using this template, Stonebridge company template, we always copy out what we have. So since this is an update that we have just added to this template, I will now copy this right now, move this right now into this template. So bar bending schedule has been added onto this Stonebridge company template, as you can see it here. And this is also the template where you can put your drawings when you're done. And if you also check in the sheet here, you also see that same thing here. You can see it here. Okay, so right now let's begin for what we are here for today, which is the bar bending schedule. This has been an issue in the body of civil and structural engineer. Most people find it difficult to prepare a bar bending schedule for a full structural detailing job or work. But here in Ekidel, using Stonebridge company template, I will show you how to prepare this bar bending schedule from start to finish. Okay, so right now, we have already done a recent work from the ones which we have already done. So this is a footing detail, as you can see it here. This is also found on the Stonebridge company template. So if you're performing a footing or a foundation detailing, you can just take a like example like this and perform your drawing to be like this. That is why you need that Stonebridge company template. Okay, so right now we will just have to now copy this right now. We'll copy this because we want to perform a bar bending schedule for this footing right now. So copy it right now. I'll copy first, copy it right now into this Stonebridge company template right now. Like I said, it is always good to create a block from so that it will be different from what you have here, because you don't copy everything that you have here. You just take similar things that is here and make sure that your structural drawing look perfectly the same way here. Okay, so right now we'll just paste it just here right now and paste it here. And so this is our footing right now. But if you check on this, our bar bending schedule table right now, you can see that the first thing that is found here is column starter bar. So we go right now. This is where we have our column setter bar. You can see it here, setter bar. So we will have to show the to prepare a bar bending schedule for this footing right now. And we will begin with our column setter bar, as you can see it here. So right now, the first thing to do right now is to begin preparing right now. So first thing to do, let me shift this directly to this point just now and keep this here right away. So first thing I do right now is to now locate. This is the column reinforcement, which is entering into the foundation, which is called a star bar, as you can see it here. So right now, the first thing to do is to check the bar mark. And in this case, this bar mark is bar mark 3, as you can see it here, 0303. So you come right here and put the bar mark 03. Okay, this already here. That was what I was working on, 03. If it is 04, you put 04. Then you go again right now again and see again what is the diameter of the bar. As you can see it here. If you check on this table right now, you can see that after the bar mark, what you're left to do again is to impute your type of bar. So our type of bar, which is the size and everything on this bar mark 3 is diameter 16. So you come here again and change to diameter 16. So I'll just put 16 here, T16. Then you come there again right now this table. What is next thing is say how many numbers? Numbers of members. So how many numbers of members? So what this thing simply means is that you have to count how many footing you have on that your building, or on that, yeah, on that your building, or how many type of member of that particular bar mark that you have on that particular project that you're working on. So in this case, we have, you can see there are 26 number doors. So I'll just come here right now and I'll put 26 here. Then right now you can see number of each. So how many number of each of these elements do you have? So I will explain this for you right now. So the number of each right now under this bar mark O3, the number of each that we have is 4. You can see it here, 4 number of diameter 16 at bar mark O3. So we have 4 number. So right now I'll go right now and put on this place number of each. I'll just put here 4. It's already here 4. Now again, I can now see number of total bars required. So this place now you just have to do 26 times this. So if you times this by this, multiply this by this, you will get the number of quantity required. So right now we'll just do calculator QC and then we'll say 26, which is here 26 multiplied by 4, as you can see it here. You can see that it is one. So you just copy it right now. Copy this one right now and put it into this place. So yeah. Then again, right now you can see length of each bar. So right now, just close this down. So length of each bars right now. So we go right now first. The first thing they're asking you for this length of each bar is to what is the length of this bar. You can see it here. So right now we go right now. This is the bar we are talking about right now. So we want to know the length from this point to this very point, as you can see it here. So we want to know the length of it right now. So to know that right now, you have to first of all check your foundation depth, as you can see it here. So our foundation depth right now, you can see it here from this point right now, from this point onto this finished floor level is 1650. So I'll just come now and say QC right now first, and I'll put first of all that from this place to all the way down to this finished floor level, you can see it here, is 1650 millimeter. So then we will also have to add our lapping, because you know that when a reinforcement comes out from the foundation, it has to lap. It has to lap with the column coming. So right now that now formed a connection between the foundation column and the ground floor column, or the first floor column. So right now the lap length is 800. I've already showed you guys how to calculate all these. So we will now add plus 800 to it right now. That gives us 2450. So right now you can see that what we have is 2450, but know that that measurement starts from here, and we have our concrete cover of 50, which is already here. I know that this bar starts from this point and not all the way down here. So we have to subtract this concrete cover, subtract this bar thickness and this bar thickness right now, so that we can get the actual length. So right now we'll just minus the cover of this foundation. The cover of concrete for this foundation is 50, so we'll do minus 50 from that overall dimension that we have just gotten. Then also the diameter of this bar, as you can see it here, for this foundation is diameter 12. You can see it here. So we have diameter 12 first, and again diameter 12 again second, because this is like a basket. It will form like a basket. So we have two. So we have to minus again minus 12 and minus again this first 12 is this one, and the second 12 right now is this one. So we'll do again minus 12 again. So we will now do equals to right now. So this gives us the outer length of this column reinforcement connection, which is called the starter bar, as you can see it here. This gives us the length from this level, from this point here, all the way down to our lapping length here, as you can see it here. So right now, this gives us 2376, as you can see it here, 2376. So go right now right here, and it is not always good. It's not good to leave your value as 6. It is always good to leave your ending value as either 5 or leave it as 0. So in this case right now, since you have, because it will be very hard to read this thing from your tape. So, but it is always easy to read 5 and 0 from your tape directly right there in your, like, at the site. So right now, since you have 2376, so I will have to approximate it to 80. So instead of me using below, it is always good to go higher. Else I would have used 2375. But it is always good to go higher. Instead of you to reduce the dimension, you have to increase a bit. So right now, I'll take the nearest round figure of this value, which will now be 2380. So right now I'll put here 2380. But even though you leave it as this place, it is also good. But just that when during the cutting of bar, during the construction, those people cutting this reinforcement will be having issue because of this smaller values which you're leaving here, 6, 7, and all that. It's always good to leave a value at 5 or 0. That is always good to like measure using your measuring tape. So right now we will now have to do 2380. Okay, so right now, the next thing to do right now is to get the total length. So this is the length of one of the bars, and we have total number of bars is 104. So we have to now multiply this 2380 times this to give us the total length of the reinforcement that will be needed for that for this building, based on just the column base foundation. Okay, so right now we will now go right now to now multiply 2380 times this. So just say cancel first and say 2380 multiplied by 104. This gives us 2. So just copy this right now, copy this immediately from here and come to this place right now and paste this inside here right now. You can see that, just right click and then paste, right click and say paste, or you say control V. Okay, so right now, then we can now come here right now and change. Okay, so first of all, okay, this our measurement here was meant for this. Sorry, it was meant for this 2380. So we will also have to add this bending. So if you check now on this place also, we also have a bending here. We have a bending here right now. You can see that we have a bend. So this bending is always 1 foot in measurement. So either you use 300 or 350, but at least minimum should be 1 foot. So I'll be using 300 for this measurement right now. But most people also use 250, but I will advise you just use 300. So I'll put here as it is here 300. Now I will now have to add these two right now to get the total length for this, so that I can now put it here. So this is the length that is meant to be here and not this one. So let me just put this as red first. So right now add this 2380 plus 300. 300. So this now gives me the total length of each of the bar. This gives me the length of each bar. You can see the length of each bar. So this is what I'll now put in here, because this one, to get this right now, you have to add this plus this. So I'll now put this right now inside this place right now. Then let me just change the color back to how it was before. Okay, so right now we will now multiply to get our total value right now. So now do 2680 multiplied by this 2680 times more multiplied by this right now is say multiplied by 104. Sorry, 104, sorry, 2680 multiplied by 104. That gives us the, so just copy it right now, copy and come to this total length right now, select everything here and then paste it here. So this is how to get it right now. Sorry for that. Sorry for me trying to omit this right now. Okay, so right now this is how to get, we have gotten the first bar mark right now for this right now. Then again, right now, we go again if we have another bar mark again for this other bar. So let us check if we have another one again for that. So right now, we have gotten this bar and this bar. So I'll just change the color so to that we will know the one that we have done. So let me change the color to like, let me use red. Okay, so we have gotten for this bar and for this bar right now. So that is gone. Next thing to do right now is to now move into this particular one because we are still under column starter bar. I can see it here. Under this place right now, we will now move on to this one right now. So column starter bar right now, we just have only one, as you can see it here. We have only one bar that we have. So right, only one bar mark, as you can see it here. This bar is same thing with this bar right now, as you can see it here. So right now, we will now have to remove this one right now. We have to remove this one. You have the right to adjust this template once you have bought the template. So you can move out this one right now and try to adjust this stuff. Let me move this right again. Then try to adjust this stuff right now using shrink. So just shrink this right now. We shrink this down to at least a reasonable amount level and just keep this here and then move this upward. So you can see how to play with this once you have this template, Stonebridge company template. Like I said, this is the updated one. So if you have not gotten this template, I'll say you should just click on the link below to download it. It's not expensive, it's just $5. If you want to be a good civil and structural engineer, because a good civil and structural engineer must be able to perform design and also be able to perform and read structural drawing very well. Okay, so right now we will now move on to this place. Like I said again, if you have not yet give my channel a subscribe button, I would say you should just click on the subscribe button so you don't miss our coming amazing videos. Okay, so right now we will now move on to the column stirrups. So what do they mean by column stirrups? Column stirrups right now, you can see it here. Column stirrups right now, which is this column stirrups right now, is this place. You can see because we are dealing only on the foundation right now. This is the foundation bar bending schedule. This is not for the superstructure. This is for the substructure. So this is just for the foundation area. So right now, this is column stirrups, as you can see. These are called the stirrups, as you can see there. So right now, let me just change this right now to columns. Let me copy this first. Let me copy just this name here. Let me change this name so you don't get confused. This now will be called column staba stirrups. That will be a good one. Okay. Column starter stirrups. Let me just do it this way. Yeah. So I can know that this is not for column stirrup, but just the foundation column area stirrups. Okay. So right now, we will now have to check the bar mark for this. This is bar mark 04. You can see it here. This points to this, all these bar markers. You can see it here. And this thing now calls out, this arrow now calls out all the bar mark and see it here. I have showed you in my previous video how to do all this. Okay, so right now, the bar mark for the stirrup right now is 04 and the diameter is diameter 10, as you can see it here. So we go right now on our bar mark just here right now, on our bar mark, and okay, it's already here, bar mark 04, and the diameter is diameter 10, as you can see there on that place. Then right now you can now see number of members. The same thing happens here. We have 26 numbers, as I've already explained here for you. This is where we got the number, total number of this particular element or this particular footing is 26 number doors appearing on this building. So right now we now put 26 here on the number of members. Then right now we will now have numbers of each. How many numbers do we have in each? How many stirrups do we have? So we count it: one, two, three, four, five, and six. You can see it here. One is here. And if you also read here, also you can also see that it is also six right now. So now we just have to impute this value now. Six number of diameter 10 of bar mark 0, 4. Okay, so right now we'll go and input it right now and put here. It's already here already. I use this template to just conclude a previous um drawing. So right now we will now have to go and we will now do this right now to now get this total number or number of total bar required. We have to do 20. This we have to do number of bar mark, which is here 26, multiplied by the number of each, which is what, 6. So we have to now do QC calculator. I'll do 26 right now, multiplied by what? 6. That gives us 156. So just copy it right now. Just say copy this right now and then come here and change to 15. Just paste it there right there. Okay, so right now we will now have to go and move what is the length of the stirrups. That the length of each bar, which is the stirrup. So right now, I'll come to this place right now. If you look at this place right now, from this column, you can see that if we that there is a section through this column which now shows us our stirrups, which is still 0, 4, as you can see it here. So we have to now know what is the length of, if you add all the length of these stirrups together, what are you going to get right now? So right now, I'll show you perfectly how to get this just now. So right now, know that we have our cover of 25, as you can see there is a cover between this place and this reinforcement, and the distance between this, which is the cover of reinforcement, to the reinforcement is 25 millimeter, and we have it on this side, on all the sides. You can see it on the side. So we have to subtract that cover right now from this overall column dimension 225. So we have to do on this place right now, we have 225 minus the cover on this side, which is 25, and again cover on this side, which is 25, minus again 25. That gives us what? 175. You can see it here. So just copy this right now and go to the bar bending schedule, which you have here, and then paste. Okay, it's already here, but you just paste it here. If in case your own is another different thing, so just paste it here first. So change this first to another color so that you can know that you are done with that. Then again, we go again to do the same thing here. Do the same thing. Since we have the same, since we have already gotten here, the same thing happens to this place. And since this is equal, you can see that you have equal values. So you also use, but if you have different value, let me say here was 300. You say 300 minus the cover here and the cover here. That gives you the length of this reinforcement from this point to this point. So right now, since we have a square column, and that means all the shapes are equal, all the sides are equal, so we'll just put the same thing as 175. And so we just copy this right now and begin to change to the next of what we have, 175 and 175. So once you're done with that, let me now change this to now to the color to make sure that we are done with this. So right now, if you take on this place also, there is also a little tying, as you can see it here. This tying is always used given to be 50. So I'll say you should use it as 50 because that's what they use. That's what they use during the construction, 50. So we have 50 here and also 50 here, as you can see it here. So right now, knowing that we have 50 and 50 here, if you go here right now, you can also see that you're tying here. So this is 50 and 50. So if we begin to sum all the length right now, we also add these 250 millimeters, as you can see it here. So right now, we'll begin to add right now 175, which is this first one right now. So we have 1, 2, 3, and 4. So we have to 175 plus 175, which is this one, plus again, this one again, 175, plus again, this one again, 175, and then plus, sorry, 175, and plus again this 50, this particular one here, plus 50, and then again plus this 50 again here, so plus 50 again. That gives us 800 millimeter as our length of this stirrup. So this is the length that the iron bender will cut before it then now begin to bend these their column stirrups. Okay, so right now we have to put here, it's already here, 800. Like I said, I use it for a work just last week. Okay, so right now we will now have to check the to that calculate the total length, the total length now required right now. We have to now do this length of each bar multiplied by the by the total number required, which is 156. So I have to now do 800. It's already there. 800 multiplied by 156 sorry, 156 number. That gives us this. So just copy this value right now. That gives us our total length to be 124,800 millimeter length. So just paste this down just here right now. Remember that we are measuring in millimeter. After everything, we have to now divide it by, convert it to meter. Then now begin to now impute the all the numbers here in kg and all that. So right now we are done with this one just now. We are done with this, right? So let's just change this colors that you don't get confused. So we are done with this one right now. Let me change the red. So anyhow we are done doing, we have to change it to like red. Okay, so right now, let's do right now is now check again. We have only one type of bar mark, but in this one, which I used in my previous example, we had two. So right now, since we have only one, I'll just remove this right now. I'll just remove this one. So when you're using this bar bending schedule, once anyone that you know it is not useful, you have the right to like remove it off from this bar bending schedule. But before you do that, always copy it out so that you can have a reference sample, right? In case if you do any mistake, you have to now go to that sample and copy it back to correct it. So once you are done with the change right now, you don't have to also shrink it again, because leaving too much space here is not good. So you have to now bring it backward again to just fit in. Let me leave it this way, okay, and bring this one downward. Okay, we are done with the column stereo. I can see there. I've showed you how to calculate the column stereo and how to prepare the bar bending schedule for that right now. And if you have not subscribed to my channel Ekidel, I'll say please help us to grow. Subscribe to my channel Ekidel, and also refer your friends and also your friends in the field of engineering to also subscribe to our channel, like our videos, and also share it. Okay, and also if you don't have this template, like I said, check on the link down below. This is a full customized structural detailing template, and this template Stonebridge is being updated almost every 2 months. It's being updated, and you until we there will be an update on this Stonebridge company template of every 2 months. There will be new things being added. Soon we will be entering into road design, and we will still be using this template because it is a template already done, um, already developed for a structural and for a civil engineer. Okay, so right now we go again right now for the next, which is pad footing. So we are done with our column starter bars, and we are done with our column starter bars stirrups. You can see it here. I'll show you this. So right now we move on to our pad footing. And where is the pad footing? This is the pad footing right now. You can see it here. This is the pad footing reinforcement on one direction, and this is also another one on the other direction also. Okay, as you can see it here, we have one direction and also one direction also. So this is the pad footing. I've already shown you how to draw this pad footing in my previous video. So you can check on our videos past, and then check how to draw these footing details. Okay, so right now we are done with our column sticker. So let me just color this one again to red. To now we know that we are done with this right now. So we'll change this right now to red color. Okay, this also to red color. Okay, so right now you can see that we are done with this too. Now we are also done with this also. Let me change to red. This column anchor, change this also to red right now. Okay, so right now we are done with that right now. We now move on to the column, onto the pad footing reinforcement to now do the bar bending schedule for that right now. So looking at this right now, the first thing you have to do is to put your bar mark. If you already known this table very well, put your bar mark. So the bar mark that we have right here for our footing, you can see it here. The first one we have, which is this, is 02, right? You can see it as 02. So we'll go right now to put our first one right here. We'll put it as what? 02, 02. Okay. Then we go again. Now, what is the diameter of bar given? Which is what diameter? What? 12. As you can see here, after your bar mark, you have your type of bar. So we have our type of bar for this bar mark O2 as diameter 12, which is T12. So go here right now and impute our change our bar mark to T12, or if you're using Y as your bar notation, you can use Y. If you're using H, use it also. But in this case, I'm using T for this example. So I'll just put T12. Okay, so right now, we go again right now. What is the next thing on our table? Number of members appeared. So how many number of members did this appear? Like I said before, it's already here. 26 number of number that this type of putting, which is 1 2 by 1 2. You can see there 1 2 millimeter, which is 1 2 by 1 2 appear 26 times. So I'll have to now go here and say this thing repeated 26 times. So I'll put here 26. As you can see, it's 26 right now. Okay, so right now again, we will now begin. What is the next thing after our bar, after our numbers of members? We have numbers of each bar. So how many numbers of each bar is found inside these bars? Like I see here, we have six numbers. You can see it here. 6 number is found in this 02 bar mark 02. So I have to now go here right now and input here numbers of each bar. You can see it here. We have six, sorry, we have six on number of each bar. So we have six just there. And also you can see, okay, we have put that right now. So now move to here right now. When we move here right now, you can now see that we have already done this right now. So to now get the total number of bars re- required, you have to now do this number of members multiplied by the number of each bar. So this will be 26 times 6. That gives us 26 times multiplied by 6. That gives us what? 156. So just copy this right now and then go here right now and put 156 or just paste the 156 there. Then now I have to now know the length of each bar right now. So we'll come to this place again right now. We will now have to know the length of each bar just now. So to know the length of each bar right now, we have to know first of all, know the length of the footing, which is 1200. You can see it here, the length of each footing. This is a square footing, 1 2 by 1 2. So right now we already know the length of the footing right now. So to know the length of each bar right now, we just subtract, as you can see it here. We have to now subtract our concrete cover left and right, as you can see it here, because here we have cover on this side. You can see the cover here. So and this cover from our design is 50 millimeter cover for the foundation. So right now I have to do 1200 minus the cover on this side first, which is 50, minus again the cover on this side again, which is 50. So that gives us what? 1100 millimeter. So I have to now copy this right now to go to this place right now, which we have here for this place right now, and then change this place right now to 1100 millimeters. You can see it here. So right now we will now have to now figure out what is the length of this bending and this bending, which I will show you just now. So okay, right now again, we have done this already. So let me change this right now to like red. Right now, we have to now figure out what is the length of this anchor for this footing. As you can see it here, this is a foot an anchor for this footing right now. So the length of this footing right now is gotten this way. Let me show you. Now the depth of this footing base is 300. As you can see it here. So this 300 right now, we also have to subtract our cover from this place and also cover at the top just here. So right now we'll do 300, as you can see it here, which is the depth of this footing, as you can see it here, of this overall footing 300, minus the concrete cover on this button, which is 50, and minus again the cover again at the top here, which is 50, minus 50 again. So I now have what? 200. So I'll just copy this right now. Copy this right now to now go and impute that just here right now. I'll have to change here right now to 200. Paste to 200 and change this also to 200. 200 and paste it there. So right now we have gotten this. So now to now get the length of each bar right now, we have to now sum this plus this plus this. That gives us the full length of of what the diameter will like cut from the full reinforcement before it now begins to now bend to this shape. So right now we now add 1100, sorry, 1100 more plus 200, which is on this face first, plus again this face of 200, this bending. So this now gives us 1500. So just copy this right now and then come here to change to 1500. Like I said before, I use this already to perform for a job for for a client, and you can see we have a lot of footing here, but in this our case, we have only two footing, 01 and 02. As you can see it here, 01 and 02. So we have to delete the rest. Okay, so right now we have gotten this right now. So to now get the total length, as you can see, total length right now of the reinforcement for the whole project right now, based on on just the footing on just one side, which is just for the Bamak O1 or the Bamak O2, sorry, we will now do 1.5 multiply this length of each footing multiplied by the total number of bar required. So we now give 1,500 right now, which is here, multiplied by the total number of that of bars required, which is 156,156. That gives us this value right now, 23,200 and 234,000. Okay, so we just copy this right now and then come here and then paste this here. So this now become our total length for Bamak O2. So you just have to now change it to red so that we don't get confused. So right now we are done for that. So right now come again right here to change this again right now to red again. Change this again right now to red again. Sorry, this. Let me just do my properties right now to change this again to red and to red and this again to red and to red. So what is left now is for this one other going to the other direction, because the one we just did just here is this particular one right now. Is this particular one right now that we just did. So we have to also do the same thing for this one also. And if you notice very well, they have the same shape. You can see it, the same shape, so they have equally the same thing. So this is already, so the next one right now is Bamak O1, which is this right now, Bamak 01. So I have to now go again right now to change again Bamak 01, as you can see it here, 01, and they have the same bar, as can they have the same diameter and the same number. So just to go the same thing again and put here diameter 12, as you can see it here, and then put the number, they have the same number of 26 number doors. So go here and change again 26 number doors, and they have the same. Let me take the length of this is 6. So if you take this right now, this is the number of members, which is 26 already, and then number of each. So how many number do we have? So we have 6 number for this Bamak O1. So come here right now and put 6 here, 6 here, and then we're right now. What do we have here right now? We have number of total bar. So we just have to multiply. This gives us the same thing. If multiplied by this, we get 156. I can see there. They have the same thing. So right now, the same thing again. You also have to measure again. Since we have a square footing, right? I can see the square footing. So I will have the same thing. So I'll just come right now and just repeat what I've already taught you. So I'll just put the same thing here, which is one. I've already shown you how to get this since they are square. So I'll just copy this again right now. Copy, Control A, Control C, and then copy and paste it here right now. But if they're not the same length, you have to, if they're not the same shape, let me say it is a rectangular length, you have to do it differently. I'm doing this because it is a square footing and they have the same thing, the same parameters. So that's why I'm just copying the one I've already done before. So if you use the same step of what we just did, you'll be able to perform any kind of barbering schedule using the same procedure. So right now, I'll just change this again right now to red to show that we are done with this. So I'll come here again and change this to red also, and then this also to red and to red and to red and red and red. Change that to red right now. Okay, so right now we are done with our foundation and also done with our column starter bars, as you can see it here. Right now, and we're also done with our column stereo, as you can see it here. Now let's move in right now. On this place, for this example that I'm using, we have a planed beam, as you can see it here. A planed beam is found just under the floor slab. You can see it there. So we have to now go right now. First of all, since our footing stops here, these ones right now, they are not necessary. So if you have this template already and you've already bought it, so just on this place right now, remove this place which you have here. Remove these ones right now. So I'll just delete them and then shrink and take this upward. So I just remove the ones which are not okay for me. So I'll just move this also, then try to shrink this now downward right now. So I'll just shrink this right now. Move this downward a bit to until it is suitable for me. So I'll leave it this way right now. Okay. So right now we are done with our column starter bars. We also come done with our column starter bars T ropes, and then we are done with our footing, our part footing bar bending schedule. Now we are moving in right now to perform this plane beam. This is a plane beam, not a ground beam. Sorry, for because this is a live project which I am working on right now. It is a live project for a client, so this is a plain beam. So let me just change it to a plain beam to avoid mistake. That should be found on this area. Let me change to a plain beam so that I can know what I'm doing. Okay, so that's a plain beam, not a ground beam. So a plan being like I said before, I used to do a practical base. All the things which I've been teaching right here in Prota Structure, they are all projects meant for clients. So it is not just for because of video, just because I want to do a video. No, it is because I am using a live project. Like if you check on our description, on our channel, we say we do a practical based project. So this is a practical based project for a client, which I'm working on right now. So that shows you how quality video and quality details which I'm giving to you. Okay, so right now we are now going to our plain bean. So just change this one to plain bean right now. If you are to do slab, you can change this place to slab or to floor slab. But for this right now, this is a plain beam. So I'll put a plain beam right now. And then right now, I'll just move this upward a bit right now. Now, to now move to our plain beam right now, you can see that our plain beam right now, you can see this plain beam, this plain beam right now. To see the full detail of this plain beam right now, all this right now, this is the detail for the plane beam. So since I am done with this one right now, let me just close this right now. Since I'm done with this, I'll just close this right now. Let me just save and then close this dialog box. This one. So this is the plane. You can see it here, plane beam details. So we will not have to now start performing bar bending schedule for this plane beam just now. So right now we'll go again right now in this place again. Bar bending schedule right now to begin our plane beam. So right now, what I'll do right now, I'll just go right now and first delete or just move this back because we are done with this right now. I'll keep this here and then go over to this place again right now to now copy my plane beam. We have three sheets or three sheets for plane beam. You can see it here. This is sheet 2, this is sheet 3. So we'll perform all the bar bend schedule for this plane beam and for this one also and for this one also. So this is the plane beam found on this entire project which I am working on right now. So right now we go to the first one now and then copy this plane beam right now. So right click and then say copy and then just close this down and then go to this place which we have which is the stone bridge complete template and then paste your project just here. Paste your project here right now and begin just say okay and begin to now work on this place on the plane beam as you can see it here. So the first bar mark we have right now from our plane beam, as you can see it here, is bar mark 22, as you can see it here. So right now, I go just this way. Let me close this first. I go right now for the first area for my plane beam and put here bar mark 22. As you can see from this table, the first thing to do is to impute your bar mark. Next thing to know that is to impute your type of bar, which is the size of bar. So we go right now. What is the size of bar? Our bar size is diameter 16, which is T16. So go right now and impute T16, not T12 that is here, T16. Okay, there we go. What again do we have? We have number of bars. Numbers of bars. What number of bar do we have for bar 22? We have two. You can see there are two numbers. As you can see, there are two numbers of bar of diameter 16 at bar mark 0 or at bar mark 20 at mark 22. Sorry. So this is read by saying two numbers of diameter 16 at bar mark 22. Okay, so right now we will now have to now go and put two number here. We'll put number here right now. So right now they're asking you number of each. You can see it here. Number of each. How many numbers do you have? Okay, so this is number of members. Sorry, number of members. Okay, so in this balance schedule, you must be very, very careful. So this is an error. This is number of each and not number. This is number of members and not number of each. So you have to be very careful for any mistake like that is done on this place. You are going to waste material and you're going to waste money. So don't make sure you don't do any mistake, right? That's why I'm very careful. Okay, so right now this is number of members is not two, because this two here is number of bars. So right now this is number of members. So we have to now count how many numbers that this Bama 22 appears. So right now, let us now start counting right now. We'll count for the entire project, as you can see it here, for the entire project I'm counting. So okay, let me just copy. I've already copied this already. So let me copy this also to this project so I can we can work it all together around. Okay, so right now I'll copy this again right now to into this place again and paste this here as sheet 2, and then say okay and copy this again, which is the sheet 3 right now, and copy this again right now, just close this right now and then paste this here. So let me now confirm if they are different. So this is bin 1 and this is okay, this bin 7 and then this is bin okay, that's been 10. So right now we can now go ahead and close all these ones right now because I've already copied all the things which I need. So I'll just say close this one and leave only the Stonebridge template active, and close this one also, and close this one also, close this also. So we now have only our Stonebridge here, as you can see it here, Stonebridge one, which I've already pasted all the plain bin that we have, as you can see them here. So right now, we will now begin to check. We have already checked our bar mark and put our bar mark and our bar number and our bar size, which is diameter 16. So this is now number of members, as you can see it here. So I have to now check how many number did this 22 appear. So right now go and say, okay, this is 22. I can see it here. I have 22 here, 22 here. The same thing happens. The same thing happens here. Let me see. 22. Okay. Let me see how many number they appear. So okay, let's start counting right now. We have 22 here and 22 by mark here and not here. It's not found here. So you have to check all the place where you can find that bar mark and then sum them up to a number. So check again, not found here, not found here, not found here, and not found here, not found here. Like I said before, this is a live project which we are doing for a client. So that's why I'm taking my time to check all this. So right now we only found 22 on this beam one, as you can see it here, and this beam one only appeared only one. So we will now have to now go here and put here number of members. We put here just one. You can see it now because it appeared only on one bin, on one plain bin, which is bin one, which is that one number does. Okay, so right now we will now have to now check what is next. Right now we now check number of each. Number of each simply means how many number of this 22, which is bar. This first one is called member, and this is for bar. So how many number of bars appear? So we're gonna right now and check on this right now. We have two top and two down, we have two top here and two number down, which gives us 4 in total. So we can now go right now and come here and then put here right now, put here to be what? 4. Okay. So right now you can now see that it appeared only on one beam and it appeared how many times? Two top, two down. So which gives us 4. So right now we now go right here right now. So and now say what next thing to do right now, number of total bar required, which is now giving us as what? We will now do 4 times this one times this numbers of each multiplied by the number of members. So in this case right now it is 4 times what? 1, which gives us what? 4. So you are saying that the iron measure will have to cut this shape, this particular shape. You can see the shape here, and they will cut this shape right now. They will cut this shape 4 times. That's what you are trying to say, that the iron measure should cut this particular shape that you're about to give him on the Babylon schedule 4 times. And when they have cut it, they should now come and read this drawing and place 2 at the top of this being 1 and 2 at the bottom of this being 1. Okay, so right now, now go right here right now. And then once we have done that right now, we have also done this right now also by doing this times this to give us this. Now we now have to now check the length of each bar right now. So I have to now go and measure the length of this bar right now. This drawing was drawn to scale. Like I said, this is a live project for a client. So I have to now check the length of this here right now, from this place to this place right now. When performing your bar bending schedule right now, let me check this. Let me check this right now. Let me check this. Okay, this thing has an issue of of dimensioning. So let me just do here right now and then modify this dimension. It is using a multiplying factor of 0.1 to multiply. So it can see 0.5. So I'll just put here 1, factor of 1. So okay, and then set as current and then okay. So if in case you have issue with your Stonebridge company template based on dimension, I'll say you should just you can just use my WhatsApp link and then WhatsApp me, send me the I'll make an update for you and just give to you back. Okay, so right now you can see that it is now working perfectly. So right now we just click on this place right now and then click on this place to check our length right now. So check on this right now and then you can now see that the total length for this right now is 9. The length of of this bar is 9825. As you can see it here, from this place right now, from this particular place right from here down to this place, which are about my 22 stops. So you can see it here is 9845 as I measured it just now. This gives us 9845. Like I said before, you must be careful when performing your problem schedule because any mistake that you do here will cost money because it will make that bar to waste. It will cost money and material will waste. So this is giving us 9825. So go here right now to impute our length for this place for the bar mark 2 2022 right now as 9825. So put here 9825. Okay. So right, let me just move it upward a bit more and they give it here. So right now, we cannot click for this bending right now. So our bending right now for this two bar mark right now is giving us as what we have to now check it right now. Check this also. I've already taught you how to dimension how to detail a beam. So if this is your first time on our channel, check on our previous video. You will see how we are able to detail this beam using this Stonebridge company template. Okay, and if you want this template, I would say you should just click on the link below. As a civil or a structural engineer, this template it's a very good thing for you to have. So click on the link below and download it. It's just $5. Okay, so right now we have to now check this also. This gives us 220 as you can see it here. So right now I'll just the same step which we took on this our footing here when we did our footing here, we have to minus this and this. It's the same step which we are going to use the same step here by subtracting the cover here and the cover at this side. So right now the overall length right now for this right now gives us what 300 for this our plane beam. As you can see it here 300 depth. As you can see it here also 300. So we now have to now subtract cover for this and cover for this. But for this beam, our cover is 25. You can see it 25 millimeter, and also at the bottom the same thing 25. You can see it here. So I have to now subtract 300, which is the depth of beam, which is this depth of beam just here right now, subtracted by the cover on both sides, which is this and this. So I have to now do 300 right now subtracted by 25, which is the first cover here, and minus again 25 again, which is this one again, and then gives us 250. So right now, we now have to now adjust this right now. 250. This now stops at this place 250. You can see there. So right now, our length for this covering this anchor right now is 250. So right now, go here right now and make this place. Where is the place? This is the place you're working on the plane beam and the first bar mark, which is 250. Okay, okay, that's already here 250. So you put it here 250 right now, and then right now we can now sum these two lengths together to now get our full length for this bar. So right now we have to now add 250 plus added by 9825. That gives us what? This value. So we just copy this right now. Just copy this right now and paste it here down here right now and paste it here. So right now we will now have to now go and check total length of of this bar mark 22. So we have to now do this our length of each bar multiplied by the number of total bar required. So we have to now do this value right now, which we just calculated, multiplied. So I have to now do um 10075 multiplied by 4, 4, which gives us this value. So just copy this right now, which gives us 40,300 millimeter. So I have to now paste this here right now. Paste this here right now. So like our culture, always change color once you're done so that you don't get confused. So I'll just change this right now to this place right now. Okay, so right now that moves us to the next bar mark right now. So I have to now go and check again. After you're done with 22, what's our next bar mark? Which is here 23 right now. So go again right now and put the next bar mark 23. You can see how I'm taking my time to teach you bar bending schedule. This is because we have already sacrificed ourselves here in Ekidel to train future civil and structural engineer to carry their career to the highest height, because that was how I was trained. I was trained by many hands. I was trained by a British engineer. I was trained by a US engineer, and I was also trained by a Chinese engineer, and I was also trained by a Nigerian engineer, and I was also trained by an engineer in Uganda. So I passed through a lot of hands, and also I was also trained by an engineer which was one of the writer of the new code Eurocode. Okay, so like I said before, if you have not subscribed to my channel Ekidel, I would say you should click on the subscribe button, because here on Ekidel, we would continue teaching you until you are good in this profession as a civil and as a software engineer. Okay, so right now we go again right now to our BAM activity right now. Okay, so right now the next bar mark right now is bar mark 23, as you can see it here. So right now, we also have to now check what is our length. Okay, first of all, what is after our bar mark, what is the next thing right now to do is to now check the bar, the type of bar, which is the size. So on this case right now, the size of bar is diameter 16, as you can see here, T16. So go here right now and type T16, as you can see it here, T16. Okay, so right now we go again right now to now check again. What's the next thing to do is to now the number of members. So I have to now count how many places, how many beams that this bar mark 23 appeared. So right now go, we have it in beam one, which is here, beam one. You can see it here, beam one. And also let's check if we have it in other places. It's not found here. Let's go to the next step. The next page is not found here. It's not found here. We have to find bar mark 23. It's not found here. It's not found here and not found here. Okay, so it is only found in the first beam, which is beam one, and that beam one only has one number. So go here right now again and impute here one number, and then we go again right now. What is the next thing is to now know the number of each. Now going here right now, how many number did this how many number of reinforcement is found in this bomber 23? So we have two top and two down, which gives us four numbers of reinforcement that the iron bender will cut out of this shape from this shape. So right now we now want to give the iron bender all the parameters he will need to cut this bar mark 23. So right now we now put here 4. As you can see, there is two top, two down, so it is now 4 in total. So right now we now have total number of total bars required. So you have to now do this number of each here multiplied by the number of members. So in this case, 4 times 1 is also 4. So just put here as 4 right now. So again, we go again right now to the length of each bars right now. You can see there, length of each bars right now. So length of each bars right now, we have to now go and measure what is the length of our bar mark 23 right now. So we have to now measure the full length of this one here. I can see it here. So measure, because there is a lapping, because it starts from here right now and then also ends here. So that gives us 2962. Like I said before, once your value ends on this kind of number, which is not 0 and 5, you have to now approximate it to the nearest whole number. So in this case right now, I will use 2965 and not 2960, because it is always good to go higher instead of to go lower. 2960, we have to decrease this length of reinforcement. So it is always good to have small excess instead of to have a reduction. So right now, instead of me to use 2962, which will be hard to like measure with tape, I'll use 2965 5. So right now the length of this bar on this side without this anchor is 2965. So I'll go here right now and put 2965. I hope you understand what I'm doing right now. So I'll put it on this, which is this is about 23, 2965. Okay, so right now the next thing they're going to do is to now show our anchor for this bar also. Since we have already done this also, and we have already calculated it here also, and it is still 300 depth, so we do the same. We have to now use the same value. I've already shown you how to calculate this, where you have to now measure the full length of your beam, which is first of all 300. You can see the depth of our beam is 300. So the full depth of our beam 300 minus it by the cover from head and the bottom here, which will now give me 250. So I have 300 as my depth of beam, as you can see it here, minus this cover of 25, and here is the same thing again. Sorry, 25. Sorry, 25, and the same thing happens here again. 25 again, 25. Okay, that gives us 250. So I'll just copy it right now and then go where we have here right now, and then where we have here, where is it? And here and paste it 250. Just paste it there or type it there 250. Then we will now have to now sum all these two values together. So add it up 250 plus, sorry, 250, sorry, 250 plus this length 2965. Okay, so right now we now have this right now 3215. So we'll copy this right now and then go to this place where we have length of each bar right now and paste it here and then put it here. Now, this is a standard bar bending schedule. You can see it here. So if you need this bar bending schedule, click on the link below and download this template. You have access to all other type of structural detailing, and this is a full Stonebridge company structural detailing. You can see it here. It's a full template for to perform structural detailing. Okay, so right now let's go back again right now to where we are before. So check on the link below and download this. This is just $5 right now, though I'm hearing that in the near future the price will have to increase. So right now let's go. We are here right now. Okay, we are on the Bama 23. Okay, this is where we are right now. So we now go again right now. Get the total length for this right now. We will do the same thing which I've taught you already before. Multiply this by this right now. So we have to do 3215, which is here already, multiplied by 4, which is the total number required. So we have this. So just copy this right now. Copy this right now into this place right now, and then paste it here. So right now we will now have to now change the color like our culture, so don't get confused. Change this right now to the ones you have already done. So right now we go again for the next bar mark again. Since you already done 23 right now, we are done with beam. We are now fully done with beam um 1. So we have no issue again with this beam again. So we have to now color this right now to red. That's our culture. Color everything here to red so I can know that you are done with this beam. So we will now move again right now to the next beam, which is beam 2. On this beam 2, we have this bar mark 24. So right now we go and put bar mark 24 just now. So after our bar mark, next to do that is now find out the type of bar. So I have to now check the diameter of the bar, which is T16. So go again right here and put diameter 16. You see a 16 here. So again, we go again right now to find out what is the number of members. How many number that this 24 bar mark 24 appears. So we now go and check to check if you can see now, you can see 24 bar mark 24 right now, not here, and it is not found here, it's not here, and it's not here, and we can't find it here also, it's not here, it's not here, and it is not here also, and then it's not here, and it's not here also, and not here also, it's not found here, and it's not found here, and it's okay. That's the end. So it is found only on this beam 2, as you can see it here. So it is found only on this bin 2 right now. As you can see it here, only on bin 2 that we can find it right now. And the bin 2 has only one number. I can see it here, one number. So go here right now and then put number to find it. Say only one number that it appeared. Only one number, only one bin it appeared. Now again, we move on down to that. Now say, what is the number of each bar? So I have to now go and count the number of each bar. We have two top and two down. You can see it here. Two top and two down. You can see it here. So that gives us four numbers. Adding together it gives us four. So now go here right now and now put four numbers. Where is it now? Put here number of each bar, which is here four, which is here number of each bar, which is four. Okay. So right now again, we will again right now to now say to now get number of total bars required. You just have to multiply this number of each bar times the number of members. So 4 times, in this case, 4 times 1 gives us 4. So put here as what? 4. Now I have to now go and check the length of each bar. So we go right now to now go and measure the length. Looking at the shape right now, the shape of this bar is like this, as you can see. Let me just copy the shape of one of these bar out. This is the shape of this bar just here. This is the shape of the bar 24. As you can see it here, 24. So right, this is the shape of bar 24. So right now we will now have to go and check if we have this shape on our bar 24 on our barbering schedule. So I have to check this right now. So tracing this right now, we don't have the shape just so you can see that. So you can just copy this right now and then put the shape to this place. Just copy and put and paste the shape here, and then you can just adjust this just now. Adjust this just right here now. So that shows that this department schedule table can be adjusted to your to the way you want it. You can also adjust to your own shape if you have any kind of shape there. So that's why you need this template. If you want this template, Stonebridge Come template, I'll say on the link below. You can see how I am stressing it, not because I want to make money from this, no, but because for you to flow for you to like follow with me or to or like for you to flow with me, you have to get this template. But if you don't have it, you can just snapshot this right now and try to create this same thing for your own. But I'll say that it for me, I'll say you should get this template because in this template we also have other type of samples which you might need. Also, you have other samples which you will need for your project. Okay, so right now we go to this place right now where we have our stuff right now here. Okay, so right now we now move on to here. 24 right now. This is our shape, and we have already gotten the shape here already, as you can see it's here. Okay, so right now we have to now know the length for this and length. We length for this and this and this. This is already constant from the ones we have done before. 250 for a beam of 300 depth is 250 in my own case. So right now we have to know this length right now. So go right now to the Bama 24 right now and then measure this right now from this point. You can see it here, not from the end, from the reinforcement to the reinforcement again. That gives us 1.6 um 1675. You can see it there, 1675. So go here right now to impute that value 1675. So 1675. Okay, so right now we now have to go and check the length of this anchor left and right. So I have to now go here and check. Let me repeat again to just show to those who don't know again. So you have to now measure the depth first, which is 300 in my own case. So 300 subtract it from the cover of reinforcement, which is 25 here, and the same thing again happens the cover here, 25 in this case. So right now, if you now do 300 right now, minus by 25 of this first four cover here, and again minus 25 again for this cover again right now, that gives us the full length of this right now from this place to this place right now. You can see it here as 250. Same thing happens on the other end too. So just remove this right now and take this off also, and go and put that 250 as we have, which already found there 250. So just put the length here 250 and also 250, as you can see it here. Okay, so right now we will now have to now go and calculate sum this up together. So I have to now say 250, which is here, plus 1675, which is this one, then plus again 250 again, which is 250 here. That gives us the full length of this bar mark 24, which is now just copy it right now and come to this place and put it. Length of each is now just paste it here, which is 2175. So to now get the total length right now, we now have to now multiply this length of each multiplied by the total number of times that this 24 bar mark occurred. So I have to now do multiplied, that value multiplied by 4, that gives us what? 8700 millimeter. So I have to now paste this just here right now. To paste this here right now. Okay, so right now again, let's need to we so since we are done with, then let me now color this right now as our culture. Once you are done with one, you have to change the color so that you don't make mistake repeating or taking any value to the ones you've already done before. Okay, so right now we now move again to the next. So we are done with this bar mark 2 because we have only one bar mark here 2024. So we can now change this right now to a color of red to know that we are done with that. Sorry, color of red, and put it as red. Okay, just now. Sorry, as red. Okay, so right now we will now go over again right now to now go and perform the next one again, which is beam 3, length beam 3. And the farmer farm there is about 25. So we go again right now and say bar mark 25 and see it here. And then we're going to say type of bar right now. The type of bar that we have here, the type of bar we have on bar 25 on bin 3 is what we have bar mark type of bar as T16. So we go here and put T16, T16 as you can see there, and then we have to now check how many number did this about 25 appeared. So I have to now check. It appeared on bin tray, which is one number does. It appeared, it is not here. It is not found here also. It is not found here either. It is not found here either. It is not also found here either. It's not also found in this one and not also found any of this place here. So you can see that it only appeared only on bin tray, and bin tray only appeared only one in this entire project. So right now, go here right now and type that it appeared only one. So number of member, as you can see the number of member only one, and then number of each. How many number of reinforcement for this 25? So we can now go and check right now. 25. You can see the 25 by mark 5 appeared two top, two down. So it appeared four numbers of reinforcement. So the iron bender is meant to cut four numbers of this shape from the reinforcement for that bent phone number of this shape. You can see it here of this shape. So right now go there and put 4. Go there right now and put 4. Okay, here 4, which is the which sorry, yes, here number of each 4, which is yeah 4 here. So right now we can put to calculate number of total bar required. So this case I've already told you what you do here right now. You just do this times this. You can see there. So 4 times 1 right now we still give us to be 4. So right now we now have to go and check length of each bar. We will now have to now check our length first. So let us check right now. What is the length of this bar as a whole? So measure from the length of the bar from this point right now to this very point. There is no lapping, so just go all the way down and keep measure here. That gives us 6863. Like I said, you don't have to leave your value with either value ending with 3, 7, or 6 or anything, but your value should end with 5 and 0. 5 and 0 is okay. So in this case right now, we are having 6863. Sorry, I'll have to end this value right now. Instead of ending with 63, I'll end it with 65 because it's always good to end the value with either 5 or 0 when performing your bar bending schedule. Okay, so right now I'll now have to use 6865. So I'll have to now use 6865 as the length of that particular one. So I'll put it here, which is where we're working on 25. So 6865. Okay. So again, right now, I have to now check the shape. The shape has a bend here and also have a bend here also, which I have just here, which I have here also. So right now, and that shape, this anchor is 250, which I've shown you before how to calculate it. So I'll just put 250, and I'm trying to make this video very fast now because I'm already taking a lot of time so that you can be able to watch it without taking much time. So I'll put here 250. 250. If you use the same way we check this, you can also get this right now. So right now we will have to now sum these values together right now. So do we will now perform, we will now do 6 8 65 plus 250 on one hand, which is here, and 250 again on the other bend again, which is 250 again. That gives us 7365. So just copy this right now. Copy this right now and come to this place, the length of each bar, and then paste this just here right now and put the value there. Now, to now get the total number which you have, we multiply this value which we just calculated right now times this 7 times this numbers of bar, which is here. So you have to now do this multiplied by this, which is total number of bar required times the length of each. So we have to now do this times this. So we have to now do this 7365 multiplied by 4. That gives us 29460 millimeter. So copy this right now as the total length for this bar mark 25. So paste this here right now. Like our culture, once you're done with anyone, you just color each red so I don't get confused or be mistaken. So right now we have done that right now. Now we go back to the next again right now. We have done 25 completely. So this bound 25, so you have to now change the color to red so you don't get confused. To now go and repeat the same thing you done before. So right now we go over to the next right now. We have bar mark 26 right now, as you can see there. And if you look at 26 right now, so we have to now put bar mark 26 right now. So we have to now go and put bar mark 26 just here right now. So right now we're going to check what type of shape do we have just now. You can see that we have shape, sorry, not shape, the type of bar, which is type 26, type 16. So we'll go right now and put diameter 16 here now and not 12, 16. Then we will again at the number of bars. You can see the number of bars right now. We have number of bars. Okay, let's check how many numbers that this 26 appeared. So let us check how many beams it appeared. It appeared in beam 4. You can see there, which is just one number. We can't find it in B5 here. It's not found in bin 6. It's not also found in bin 7. It's not found there. And in bin 8, it is not found here. Also, in bin 9, it's not found here. In bin 10, we can't find that bar mark 26 here. In bin 11, it's not here. What is here is 31. In bin 12, what is here is 28 and 29. And in bin 13 is not found here also. I think that's the last. So it is only found in bin 4, which only have one number. So we have to now go here right now and put in one number that it appeared. One number. Okay, so right now, we now check numbers of each. How many number of reinforcements is found in this number of 25? This one we did before is how many members, quantity of elements. But now this like let me say the number of house that you're about to build. Now this one right now is saying how many reinforcement they found in that particular. So we have to now check how many number of reinforcement is found in this one 25 right now. So I have to now check bar mark 25, sorry 26, not 25, 26, okay, yeah, 20, 26, okay, 26 has a number of two top and two down, which gives us four numbers of reinforcement. So the iron bender is meant to bend four numbers of this bar mark of this shape. So put there four. Now this place right now, which is called number of total bar of number of total bar required. So you have to now do this multiplied by this right now. So I have to now do 4 times this, which gives us same thing as 4. Okay, so right now we're gonna go again right now to now calculate length of each bar. So I have to now go and check what is the shape of this bar just now. What's the shape of this bar right now? So the shape of this bar is the same shape. We have our bent on this side and also bent on this other side also. So right now we now have to now check the length from this bent up here to the last end bent up here, which gives us what? 7188. Like I said, it's always good to end your value with 5 and 0. So in this case, right now we have 7188. So I would say, for me, I'll use 7190 because that is the nearest whole number is 90. So I'll use 7190. So right now I'll go have to go and put there on this place right now. This is the Bama 26. You can see it here 26. So I'll put here 7190 7190. So I'll put here 7190 there. Okay, so next thing right now I'll do is to now check my bending. This bending, what is the length of this bending? Like I said before, the length of this bending is being gotten by the depth of the beam subtracted by the cover of the reinforcement top and the bottom one also. So in this case, it should be 300 minus 25 at the top and minus 25 again at the bottom again, minus 25 again. That gives me 250. So right now I'll go and put 250 right now as my bending. As you can see at my anchor bending here, 250, which is already here, 250, and then also 250. Okay, so right now, let me just shift this a bit. Okay, so right now we will now have to now check the total length. Sum this up right now. So sum this up, say 250 right now plus this one 7190 plus again 250. So 250, that gives us 7690. So I have to now copy this right now and put it as our length of each bar. So this now gives us 7690. So just paste this right now here, paste it there. Then to now get the total length of bar right now, as you can see there, we now multiply 7, this one right now times this right now. So it gives us 7690, which we have here, multiplied by this total quantity or total number, which is 4. So that times 4, that gives us what? 30760. So 30,760 millimeter as a length. So paste this here right now. Copy that one and paste this here right now. Okay, so right now we are done with this one. So let's just change the color as our culture to change, always change the color. Once you're done with one, change the color. So right now we now move to the next bar mark. So that will not change this color first to red right now. So now move to the next bar mark right now, which is bar mark 27, as you can see it here. So 27 bar mark, you can see it here, bar mark 27. So go here right now and impute that value 27 27.7, then check the type of bar, which is bar what 16. So go here right now and put bar 16, 16, as you can see the 16. Then we go again right now to now check how many numbers did this bar 27, how many beams on how many beams did this bar 27 appeared. So it appeared in beam 5, as you can see it here, and it is not found in beam 6. It is not also found in beam 7, and in beam 8 it is not found in beam 8, or not also found in beam 9, and in beam 10 it is not found. In beam 11 it is not found. In beam 12 it is not also found. In beam 13 we cannot find it here. So it is only found in beam 5, which has only one number, as you can see it here. So we have to now go there right now and put in one number, which is here, one number for 27. So right now we now have to now check number of each. How many number did it appear? So we now check what? We now check this, two top, two down, which gives us 4 numbers. So we'll go here right now and gives us 4 numbers. Okay, so right now we now have to now check um number of total bars required. So that we now have to do this multiplied by this. So that gives us what? 4 times 1 is sitting as 4. So we'll put here as 4. Okay, so right now we will now go again right now to now check the length of each bar. So go here right now to now check the length of this bar right now. We measure this from this down to this point. That gives us 5175. So go here right now and put in 51. Can let me see there 5175. 5175 and put this in there. Now looking at the shape, the shape has bending on both sides, as you can see it here, and not on one side. So you have to now let me now copy this right now. That's why I say you can edit this template to the way you want. That's why as a good structural engineer, you need this. If you want to be a good structural and a good civil engineer, you need this template, Stonebridge company template. It is designed to perform just civil engineering and structural engineering structural detailing. Okay, so right now we now go right now and just adjust this. So right now, I have to now check the bending for this. What is the bending for this right now? So just check it out for just here right now. So check this right now. I've already shown you how to get this bending right now, and also how to get this also here. So right now, in my own case right now, the depth of the bin is 300. So if I subtract my cover both and right, I'll have 250. So I'll just put here 250 right now. I'll put here 250 as my bending, and also the same thing here 250 as my bending. Also, if you have any comment regarding this template or or this bargaining schedule which I'm doing right now, I'll say you should leave the comment down below, and you can also use our WhatsApp platform on the link below and also message us. We'll also reply you either through video call or voice call. Okay, so right now we will now have to now sum this up together right now to now get the length of each bar. So I have to now sum it up. So I have to now do 250, which is here, 250 right now, plus 5175 plus again this 250, which is 250. That gives us what? 5675. We copy this right now, come to this place, length of each bar, and then paste it. Just paste it here just now. Paste this here right now. Okay. Then right now we will now have to now get the total length of this bar mark 27. We now have to now do this length of each bar multiplied by the total number of times it occurred. So now do 5675 multiplied by 4. Okay, so that gives us 22,700 millimeters. So now copy this right now and put it here right now. We are almost done with this class for today. So again, right now, we now move again right now to now check again. We still have bar mark. We are done with this also. We'll just change this to red as our culture. Change to red right now. So we are now left with bar mark 28 right now. And you can see that we don't have space again to also we will now have to now stretch this bar bending schedule right now table to now get extra tables, extra space to now input all our tables. So we will now have to now copy this. Just let me copy this right now. Copy this 27, which I've already done. Copy this and put this here first, and then let me just take it off. Now, since we are done with, let me just copy change this one to a color as our culture. Once we're done with one, change to a color. So change to 27 right now. Okay, so right now we will now move to perform BAMA 28, as you can see 28 right now. So we have to now change this right now to BAMA to put this right now for the new one 28 right now. Okay, so right now we will now go again to check what is the size of the bar. So in this case, it is 20, it is 16. So I'll put here as 16, as you can see it here, 16, T16. And then right now, check how many numbers that this thing appeared, as you can see it here. We check how many numbers of times this particular bar mark appeared, how many beams it appeared. So we now go right now. We have bar mark 28 in beam 6, as you can see it here. If we go again, it can be found in beam 27. It's also here, you can see it here, 27. It's also here. Sorry, it is found in bin 6, as you can see it here. We found Bama 28 in bin 6, and also it is also found in bin 7, as you can see it here. Also found in bin 8, as you can see it here. Also, it is not found in bin 9. Also found in bin 10, as you can see it here, and also found in bin 12, as you can see it here, not in bin 11. Also found in bin 13. So now count how many numbers that it all appeared right now. So let us count right now. We have it in beam 6, which is just one number doors. You can see it here. So we have to clear and say 1. We have it on beam 6, which is one number doors. And we have it again in beam 7, which is 1 again. So we say plus 1 number doors again. We also have it in beam 8, which is 1 number doors again. So put here again plus 1 number doors for this. You can see it here. We also have it not here. We also have it in beam 10, which is also 1 number doors. So put here plus 1 number doors. We also have it in beam 12, which now has, you can see there, 2 number doors. You can see it here, 28, which now 2 number doors. You can see it here. So put here plus 2. Okay. We also have it in beam 13, which has one number does. Can see it here. So put plus one. Now do equals. So we'll have it seven in seven beams that it is appearing. So put in that place number of members. You can see it here. I'll put here seven. Now you can see the difference. In other ones we have been doing, we have been getting one, but now we are getting seven right now. So right now, we now go again right now to now check what the next to do is now check number of reinforcement in each of the number. Since we have seven numbers, now they are asking us how many number of reinforcement do you have in one. So we now go again right now. We have two top, two down. As you can see, almost all of them where they appeared is two top, two down, and two top, two down, and two top, not here. Also here, 28 here, as it appeared, two top, two down, and also here, two top, two down, and two top, two. So it's found in each of the members, two top, two down. So which is four. So two plus two is equal to four. So I have to now go here and put here four. If in your own case it's two top, three down, or two top, five down, so you have to add this plus this. So in this case, you have two top, I have two down. So two plus two in my own case is four. So I have to now put in each of the member, it appeared four numbers of reinforcement of that shape, So right now, we will now have to now calculate number of total bars required. So now do four times seven, which is the number of reinforcement on each member times the total number of members. So that do 4 multiplied by 7. That gives us 28. So put here 28. You know how I got 28? I do this, multiply this cell, multiply by this cell. Okay. So right now, I will now have to now go and measure now go for the length of each bars. Now length of each bars right now enters now goes now go and check the shape of this 20 of bar 28. The shape is, let me check the shape. I'll just highlight the shape right now. The shape is not all the way down. Okay, it is only bending on one side and have a lap here. So bending only is only on one side, right? I can see it here. So right now, I'll now go and change the shape first and remove this bending on one side here and leave only on one side. So now let us now go and measure what the shape is right now. So measure from this point right now all the way down to this point where we have our lapping. And what's our length? This gives us 11,000. As you can see there, 11,000. So we go right here right now and impute our length on that bar mark 28 as 11,000. As you can see, the 11,000, you can see there. We put that 11,000, as you can see there right now. 11,000. Okay, so right now we now go to check this bending. I've already shown you how to check the bending. I have to calculate that. So in my own case right now, it will give me 250. Like I can see, we have already been dealing with 250 before. So in my own case, this is 250. I've already shown you how to calculate this bending. Okay, so right now we will now have to now sum this right to now get the total to get the length of each bar. So we have to now do this 11,000. Sorry, 11,000 plus this 250 here. This been 250. This gives me 11,250 millimeter. So I'll copy that right now and come here and then paste this here just now. Paste this here, right click and say paste. Then now get the total number of length right now. We now have to now do this total number required multiplied by the length of each bar. So I have to now do this 11,250 millimeter multiplied by 28, which we have here already. So that gives us what? 315,000 millimeters. So now go here right now and put that and paste it here right now and change it. So right now we have done with bar mark 28. So if you check it also on this same beam 6, we also have beam bar mark 29. You can see it here 29. We also have it here, bar mark 29. As you can see it here, this should be found in this place. This should be found here. This should be found on here. Okay, here. Not because not on this place, on this bar mark. Okay. So right now, I can change this later on my job here. So let me just go down right here to change it from the previous, because like I said before, this job is for a client. So I'll just, if I have made a mistake, okay, it is not found here, it's not found on this place, I'll just close this down, just close it down. And let me check where I have that mistake. Like I said, this is a practical based project I'm working on. So if I didn't mistake, it's going to affect me. So okay, after I'll do that, after I'll just do just that. Okay, so right now let's just begin on what I'm doing right now. So right now we're done with 28. Now begin with Bama 29 right now. So right now I'll just go right now to now add additional table for that. So I'll just copy this table, this one right now, copy this table right now, and then bring it downward to 429 and put here 29, 29 bar mark. Okay, so right now, oh, I'm gonna change this because I done with this one. Change this one to red right now. Change this one to red because we're done with that right now already. So right now, we will now have to now do for this, right, which is 29 right now. So 29 right now is already found here. It's found in beam beam 6. And I think anywhere beam 28 was found, you also found beam 29 because they have the same similar stuff. So right now, let us check the first of all check the size of the bar, which is T16. So go here and change to T16, diameter 16. Then also check how many number of members where they appeared. So let's count again. The same thing with this one on Bama 28. So it appeared in bin 6. You can see it here. In bin 6, it appeared in bin 6. You can see it here, bin 6. And also in bin 7, it appeared here also. Also in bin 8, also in bin 8, it appeared here. But in bin 9, it is not found there. In beam 10, it appeared here also. You can see it here. It appeared here. In beam 11, it is not found here. In beam 12, it is found here. Okay. In beam 13, it is found here also. So let's now count how many number they appeared. So it appeared in beam 6, and beam 6 is just one number. So say 1. It appeared in beam 7 and it's just one number. As you can see it here, one number. We say plus 1. It appeared in beam 8. You can see beam 8 and beam 8 is just one number. So plus 1 again. It didn't appear in beam 9. So it appeared again in beam 10. As you can see it here, beam 10 and beam 10 is only one number. So say plus 1 again. It appeared again in beam 12, which is found two numbers. Can see it here. So say plus two numbers. And it is found again in beam 13. You can see it here, found in beam 13, which is just one number. We say plus 1 again equals to 7. So go here right now and put number as 7, which is almost the same thing as 28 as Bama 28. So just say sorry, 7. Okay. So right now we now have to go and check number of each bar. So how many number did they appear? So it appeared two top and two down. And that is what is found in all the places where it appears two top, two down, two top, two down, and then two top, two down, and two top, two down, and two top, two down. So go here right now and impute that. And 2 plus 2, you can see it here. In my own case, 2 plus 2 is 4. So 2 top, 2 down. So the iron bender is meant to bend 4 numbers of this shape. It's going to bend 4 numbers of this shape for each member. So multiply it by the total number of half, which is 4 number of half. So if you do this times this right now again, right now, that this times this gives us 28. So right now, this have 28 right now. 7 times 4, 28. So 28 will be here. So right now, this gives us 4 numbers, what I said before, 4. And then to get this right now, to get numbers of total bars, you have to now multiply this times this. That gives you this total number, which gives us 28 in this case, because 7 times 4, 28. So let me just say 27 times 4, 28. That's true. Okay. So sorry, 7 times 4, not 7 times 4, 28. Okay, that's true. So right now we have to now go and check the length of each bar. So I have to now go and check the length of this bar mark 29. So I have to now go and measure it right now. So just say measure from here, from this point to this point. So that gives me, you can see it here, 3475 without the bending, just the length. So I go here and put, where is it here, 29? I go here and put 3475. Okay, and then I've already told you how to get this bending, where you have to now do this beam depth mi- minus it by the cover at the top and the bottom. That gives that will give you the bend. That will give you the length of this of this anchor. In my own case, I've already done it, which gives me 250 in my own case, just for the steps which I've done before. So 250. So to now get the total length of the full length of this of one bar, which is the full length of each length of each bar, that now do this plus this. So now do 3475, sorry, 34775 plus 250. That gives me 3725 millimeters. So I'll put this right now for length of each bar first and paste this here. Okay, paste this here right now. So right now, I'm gonna have to now go and multiply to get the total length right now. As you can see, total length here. So I'll do this times this right now. So I'll do times, sorry, 3725 multiplied by 28 by 28, sorry, 28. That gives me 10 204,300. So I'll just copy it right now, come here and paste this right now. Paste this. Okay, so let us take a break right now. If you have not yet subscribed to my channel Ekidel, I'll say you should please subscribe to my channel Ekidel. Support us to grow by sharing this channel to your friends. Share this channel to your friends, Ekidel. Share it to your friends and tell them what we do here. If you're a student, I'll say you should also make your fellow student to also benefit from this structural design and detailing which we are performing here in this channel. So share this channel, and if you have not subscribed to my channel Ekidel, I'll say you please click on the subscribe button. And if you also have a comment based on what I'm doing right now, I'll say you comment and put your comment down below and we will reply you immediately. And also, if you, I would say you should also share this video to your friends and family and click on the like button. Give us like a thumbs up. Okay, so right now let's begin right on the next begin right now. So right now we go to now, since we are done with this right now, we now go to the next. After we'll have to change the color, but right for let us change this first of all because we are done with this right now. We'll change this one down to a color of red. So let's check where we have 28 and 29 and change the colors. We have also done the same thing on this other beam. Change again to this color again. Change it. We are almost done with today's tutorial for this bar bending schedule. Also change this also because we are done with 28 and 29 bar mark. Also change this. We are done with this also. Change this also again. And then change this also again. We are done with this. Okay. And also we are done with this also. Okay. Now we are left with only bar mark, um, bar mark 30 and bar mark 31. So we are almost done with today's tutorial. You can see how long it took us because like I said, this is a practical base and this project is for a client. So I'm using to show you how to prepare a bar bending schedule. It is very hard to see this kind of detailed video on YouTube, but we are taking our time because we have already satisfied ourselves to train good civil and structural engineer right here on our YouTube channel Ekidel. So right now, we will now go right now to now copy this first to duplicate it to bring out for Mark 30 and 31. So just copy and paste this here right now. Let me remove this duplicate that is here already and then change this right now to a color because we are already done with this one, like our culture, as you know. Then put this one right now to bar mark 30, 30. Okay. So right now, we're going to take bar mark 30 right now. Bar mark 30, you can see the shape. The shape, it has bending on each side. But first, let's check the size, which is T16. So go here right now. Under the bar type, the type of bar, we put T16. If in your own case, you're using Y or H as your bar notation, you put it. But in this case, we are having diameter 16. So put it there and the notation is T. So right, we go again right now and check how many numbers, what number did this max 30 appeared. You can see the number of members. So we go here right now. It appeared in beam in beam 9 and only beam 9, it is not found here. So only found in beam 9, and beam 9 only has one number. So go here right now and put in one number. Okay, so right now we go again on number of each. You can see it here. Number of each. We now go how many number of reinforcement they found in each of them. So we have now you have two top and two down. So 2 plus 2 is 4, as you can see it here. They have the same bending, two that's per 30 and per 30. So we just add this plus this is 4. So go here right now and put here 4. Okay, so right now, we're now going on the next one, this number of total bar required. So you have to now multiply this times this. Now give 4 times 1 in this case will give me 4. So I just put 4 in this case. Okay, so right now, I go again right now to now say length of each bar, right? I can see there, length of each bar right now. So I have to now go and measure the length of that bar. I have to now go and measure I'll have to measure right now from this point to this point right now, and that gives me 9140. Okay, so I'm now going to put it here 9140, 9140, 9140. Okay, I'll then copy this again right now because the shape is having this kind of shape. So I'll copy this shape and put it here. Okay, so right now, after now, let me just adjust this right now. After I can check the length of this bending left and right on beam on this bama 30. So I have this shape as you can see it here, and also this shape also. So I can now go and check the length. So this the length of my beam. First, the depth of my beam is 300. So 300, which is the depth of the beam, minus the cover, which is found here 25, as you can see 25 here, and minus the same thing again, cover again to reinforcement 25. So I have to put 300 minus this cover 25 upward here, and minus 25 again downward here, cover. In my own case, your own case, your cover can be 30 or 35. So use your own case. So right now I have 250. So I'll copy right now and go and put it here 250 on both ends. So I'll just paste right now. I can say paste and then also paste it here 250. So right now, I will now have to now add up the values together, sum them up to now get the first of all length of the bar here. So I have to now do 9140 plus 250 plus again 250. That gives me 9640. So I'll copy this right now and then come here and then paste this just here right now. Okay, so this is what I now have right now. So right now I get the total number of length of bar, as you can see it here. I have to now do this length of each bar, as you can see, length of each bar right now, multiply by this one here, by this total number required. So I'll do this times this right now. So I'll do 9640 multiplied by this one, which is 4. That gives me 300 and that's 38,560 millimeter length of bar. So I'll just paste this down right here. Okay. So we are done with this bar mark 30. I'll just go right now and change the color as our culture so don't make mistake to a red. Sorry, to red. Let me change to red as our culture. Always change to red. Okay, so right now, we now go over right now for bar mark 31. As you can see it here, this is our last bar mark. So we will now go again right now. So now copy this just now, right now, and keep this here to form bar mark 31 table. So 31 as our culture. Once you're done with one, you just change the color. So let me change one to like red right now. Okay, so right now, bar mark 31 right now, let's go and check what the size of the reinforcement is. So we now go to bar mark 31, which is left just now. All these ones are just the section, as you can see it here, where we have to use this section to now check our links, or yeah, the bin links. So right now, we'll just go right now to check. We have diameter 16, so we have to go and put here diameter 16. Okay, and then how many number, the number of bars, number of members, sorry. Okay, so number of members, how many numbers of beams that this Barmark 31 appeared? So you can see that it appeared only in beam 11 and it has only one member. So we now go right now and put beam just number one, because that beam 11 where it appeared is just one number does it appeared in the whole entire project, in this whole project. So right now, we now go again right now to now check number of each, which is the number of each bar. We have on this bar 31, we have two number top and we have two number bottom. So we now add it up, that gives us 4. So now go right now and put in here 4. As you can see it here, put in here 4. Then right now, we can now go and check number of total bar required. This place just do this multiply by this will gives you this number. So in this case, 4 times 1 gives me 4. Okay, so right now, I will begin right now to now check again length of each bar. So I will now have to go and measure the length of the bar right now. So I have to go and measure this length just now. Measure from this point and to this point right now. This gives me 4775. So I'll now go right now and go and put in this place 4775 without the bending 775. Now I'm now going to check for this bending and for this bending also. Now on this case right now, on this place right now, you can see it here. We have a bending here and we also have a bending here also. And I've showed you how to do this bending to calculate this right now. In this case, my depth of beam is 300. You can see it here, 300. So 300 minus the space, minus the cover, which is 25 here at the top and also here at bottom 25. So if we do 300 right now, subtract it by the cover at the top here and at the bottom here, which is 25 minus 25 again, that gives me 250. So I'll just copy this right now, 250 right now, and then go all the way down here and paste it here, 250, right click and say paste, and then also the same thing here, right click and say paste. Okay, so right now we will now have to get the full length of this bar right now. So I have to now sum it up right now, say 250, which is this one first, plus 2 plus this one 4775 plus again 250, as you can see it here, 250, that gives me 5275. So I'll copy it right now, come to this place where I have my length of each bar and then paste it here where I have this place and then paste it here right now. Now get the total number, total length right now. The total length right now, now do this length multiplied by this number. So I have to now do this 5275 multiplied by this value, which is 4 right now. Sorry, 4 equals to, that gives me 21,100 millimeters as my length of this bar mark 31. So right now we have come to the end of all our bar mark for the bar. So we now move to what we have as our now coming here again right now we have stick ups. I can see it here, the links. You can see the links here. We have not done for this thing. So let us change this first to this color red as our culture red. So right now we have our links. You can see it here. We have our links. So we have to also check, because the one we just concluded is all these bars. You can see it here. We have two top and two down. I can see it here. So right now we now have to now check the link, which is this link binding all these 4 bars together. As you can see that we have bars here. So I have to now check for the link here and for the link here. We have to now check the total number of links required. And if we check under our on each of these beams, it has a bar mark. You can see it here. Let me show you how to read this. This is being read by 16 number of diameter 8 at bar mark at bar mark 35 and our spacing 225. You can see that that's what we have. We have the same bar mark on all our beams, because since our beam has the same depth of 300, so they will have the same bar mark. You can see it here, bar mark 35 and bar mark the same thing, this sheet 35 again, and the same thing on this sheet 35 again. See here, 35 bar mark 35. So we have to now go and change our link, our beam link as bar mark 35, as you can see 35 here, 35, sorry, which this is our link, as you can see. This is too big. Let me just reduce this cell to enable them, shrink this a bit, shrink it a bit, okay, by using stretch. Okay, so right now, what is the size of our link of our beam link. So let us go right now and check. This the size is T8. So right now I'm going to take diameter 8. So put diameter 8 here, diameter 8 here. Okay. So right now put diameter 8 just now, diameter 8, as you can see it here. Okay, so right now we will now have to now diameter 8. That's what we have here. So right now we now have to go and check for this number of members and number of each bar. But in this case right now, I'll show you how they do this right now. Since we don't have the same uniform length of beam, you can see that the length of this beam is different from this beam. So right now for links, what you do is to sum up all the numbers. So instead of you putting this outage, leave here as dash and leave this place as dash, and then sum all the number of the total bars which you have here and put it here. So how do we get this right now for this link? Is to now go right now and begin to sum. You can see there we have total number of link occupying this span, and also on this span which is 5, and also on this span which is 21, and also on this span which is 6. So we have to now sum them all together. So in this place right now we have 16. So we have to now start summing them. So we have 16 plus, on this span we have 5, so plus 5. On this span we have 21, as you can see it here, so plus 21, plus on this place we have 6 numbers, so plus 6. And then on this here again, on this beam 2 right now we have 5 numbers, so plus 5. Then go again right now, on this beam 3 we have 21 numbers for this span, so plus 21. Plus here again we have 6 numbers, so plus 6. Then here again we have 6 numbers. Please check if I'll make a mistake. Then just give me a comment. Then again we have 16 here, so plus 16 again. And then here we have 5 plus 5 again. And then here again we have 21 on this place, so just say plus 21 plus 21. Then again we go again, we have 6 here plus 6. And then we have again here 23, as you can see it here, so plus 23. And then again we have again here plus 21, so say plus 21. And then again we have again here plus 6, say plus 6 again. And then we go to the next sheet again right now, the same thing. We have plus 6 here, I'll say plus 6. And then we have plus 23 here, I'll say plus 23. And then again, we have plus 8 here, we say plus 8. And we have here plus 12, we say plus 12. And then we have again, we say plus 6, we have plus 6. And then the next beam we have on the beam 8, we have plus 17. So we say 17 plus again, we have on this beam, we have again 23 again, plus 23, plus again, we have 17, we have say 17, plus again, on bin 9 we have 25, say plus 25. Then plus again we have 12, say plus, sorry, we say 12. Okay. Then we also again we have again plus 6. So we go on this bin 10, we have 6 plus 6. Then we again we have 18, so we say plus 18. Then we again we have 12, so we say plus 12. And then we get, sorry, plus 12, not 2, plus 12. And then we have again plus 19. You can see it here, 19. So we say plus 19. And then we also we have again on beam 11 plus 19. We're almost done. Plus 19. Then we have again here on this beam 12. We have the first one plus 6. Plus 6. Sorry, this was plus 19, not 9. This was plus 19. But we put here as, no, let me put here back 19. Please check for me if there's any mistake. Okay, so we go again right now. Just go backward. Where we have it here. Okay, we have done 19. We have done this 6 also. Now we have plus 18, as you can see it here, plus 18. Then again, right now we have again plus 6, as you can see it here. So plus 6. Then again, we have again here plus 11. So we say plus 11. So we have again here plus 14. So we say plus 14. And then we have again here plus 13. Sorry, plus on bin 13 we have plus 26. So we have plus 26. And then we have again here plus 12, so say plus 12, and then we have again here plus 19, so say plus 19. So that's the end. That's the end. So now say equals to, that gives us 519 19 pieces of this size of length, this shape that the iron metal will like cut. So we'll copy this right now and then go to this place on our table, Babylon's table right now, and then come here and paste it here and paste this here, that the total number, you can see total number is 519. So which means that the diameter will be, we have to bend the shape that we are going to give in here 519 numbers. So right now we have to now check the length of bars. You can see it's the length of bars right now. So length of bar right now, we now have to now go and put the length of bar right now for this here right now. Length of bar, we now have to now go and calculate it right now. So we now go to this shape right now here. Now on this place right now, this shape, this side is 225. So 225 minus the cover 25 here, 25 here. So 225 minus the cover of 25 on here and here. So 25 minus 25 again, that gives us what? 175. So we have 175 here and also at the top here. So right now we'll go and put it here, which I already have here, 175, 175, and also here 175, sorry, 175 again. Now what can now click for this other place here also for this other side, which is for this side now also for this side. So this whole full length of this beam is 300. So we have to minus the cover, which is here also, and also the cover again, which is also on this side. So I have to say 300 right now minus 25, which is the cover of reinforcement here, and also here again. So 25 again at the bottom, 25, which gives me now 250. So I'll go here right now and then put in 250, 250, 250, and again 250, 250. Now, then the same thing happens here again. If you click again, we also have a small tie here. You can see just small lapping or small tying. This tie, as I said before, is always 50 millimeter, 50 millimeter. So we now have to go and calculate all the total length right now. So this is 50 and 50. So we have to now start right now. 175 plus this one plus 250 plus 250 plus again 175 here plus 175 plus again this one again 250, sorry, plus 250 plus 250, then plus again this lapping for this length 50-50, so say plus 50, sorry, plus 50 and plus 50 again, which is for this and for this one and for this one and for this one. So now say equals to that gives us 950. So I have to now go right now and put here 950. So put here 950. Let's confirm again if that is true. So 250, which is this one, plus this 250 here, 250 plus again this one 175, 175 plus again 175, which is at the bottom here, then plus again this 250 overlapping 50 plus 50, that gives us 950. So that gives us the length of one bar as of one bending of the link as 950. So multiply by the total number of the link which you have for this entire building, which is 519. So right now we'll say 950, which is already here, multiplied by 519, which is the total quantity of link required for this entire project. 519, that gives me 493,050 millimeter. So I'll have to copy it right now, come here right now, double click right now, and then paste it inside here, paste this. So right now, I'll now change this again now to red again. Okay, so right now we have done all the bar bending schedule and given out all the bar mark and given all the shapes and the length which the iron bender is meant to cut, and which from this right now they can go and from our next video we'll have to perform our BEME, which is beam building, like to that check the cost estimation for this whole project. So if you have not subscribed my channel Ekidel, I would say you should click on the subscribe button so you don't miss all this video and you don't miss this awesome opportunity on training you guys fully on the design of civil and structural um, members. Okay, so right now we have done with all this right now. So we will now go over right now to now calculate, to now give a summary of what all we have found, all what we have done here. So I have to now give a summary right now. And the summary, we have now gone sum up all the lengths of diameter 16, 12, and 10, and also 8. You can see we have 8 here. Okay, so right now we will have to now go and sum them up right now to now get what we want. So we have to now go and sum it up just now. So let us start with 16 right now. So we have to go and locate all the 16. So I'll first of all find all the 16 first and change them to a color of blue. So I don't do mistakes. So I'll find all the diameter 16 bars and change them to a color of blue. Okay, that's all. Okay, this also. So I'll change it to color of blue right now, and then find also the where the lengths are. The length also is here. That is total, you have to add the total length, not this one, the total length of it. So we have it also here and also here and also here. I think also all the way down here. So I'll change them to color blue first, so I will not make mistakes. So right now, I want to sum up all the diameter 16, all the total length, and then put them here in meters. Why here is in millimeters. So we have to convert it to meters. So right now, let's start adding right now. So I have to start adding right now. So I'm clear here. Now start with here first right now. So I'll say 278720 plus, move to the next again now, 4300, 4300 plus this one, 12860, 12860 plus, go again here, 8700, 87100 plus 29460, 29460 plus 3760, 3760 plus 22700, 22700 plus 31, 315000. So 315000 plus 104300, 104300 plus 38560, 38560 plus 21100, so plus 100, sorry, 100. Okay, that's all for them. That is 16. So I'll now do equal sign. So that gives me in millimeters. So I'll now do divided by 1000 to convert it to meter, because our final summary here is in meters. So I'll do divided by 1000 to convert this millimeter right now to meters. So I'll do equals to, that gives me this value. So I'll just copy it right now. This is my total length of diameter 16 for this entire project. I'll now put it down here right now and paste it here. Okay, so right now, once you paste it here right now, you now have to now multiply it by the unit length. This unit length are standard. You can get this from Google. Just ask what is the unit length of diameter 16 reinforcement, side of reinforcement, you just the table. So in this case, right, this is 159. 1.58. You can also verify from Google. Just ask Google what is the unit weight of diameter 16 reinforcement, and you will get this value right now. So once you do this right now, you have to now multiply this value right now by the unit weight to now get the total weight in kg. So I will now have to now multiply this value right now, multiply by one of the unit weights, which is for diameter 16, which is times 1.58, which gives me this final value right now in kg. So right now, I'll just put this right here. I'll just paste this right here now. Now you can see that I always like leaving my value in one decimal place. So I have to approximate this right now. So if I approximate this right now, this will now give me 0.303, and I'll also approximate again. Normally this cannot be approximated because 3 cannot approximate, so I'll not leave it in 0. I'll just put 1 right here. Okay, so right now I'll now move to the next again right now, diameter 12, as you can see it here, diameter 12. So I'll now have to now go to diameter 12 right now, diameter 12, as you can see it here, diameter 12, which now gives diameter 12 right now. So I'll now change this back right now to all the way to red, all the 16 back to red, 16 to red, back all the way to red. So I can now color my diameter 16 to blue. So the 12 to blue. So we are now working on 12 right now. So I'll locate all the diameter 12 of side of reinforcement, then change them to blue, right? I have only two, as you can see, the only two I have only two. Okay, I have only two right now. So I'll now go and also change the length to blue, then I calculate it. So right now I'll now calculate sum up the length. Sorry, change to blue right now. Why is not changing to blue? I don't know why. Okay, so I don't know why. So right now, we'll now change these two right now to, we now have to calculate this right now. So I'll calculate this right now. These two right now, these two. Because these two is only for them that 12. So I'll now sum them up right now. So 234,000 plus 234,000 again. Okay, do we have similar thing here? Yes, we have similar thing because of the footing. It came from this footing which we did before. Okay, so right now we now have to now sum all together right now. So just plus again 234,000. Okay, so right now just do equals to divided by the by to convert to meter. So divide by 1,000, 1,000. That gives me a value. So I'll copy this right now down to where we have here on the meter 12, as you can see it here. Paste it inside here. Paste this down here. Paste this down here. Okay. And then I like to leave my value in decimal place. I'll just put point 0 dot 0. Okay, so right now, then let again multiply again by 1 unit length. This one I'm got it from Google. This is a constant. So multiply it right now again. 468 multiplied by 0.89, which is for 1 unit weight of diameter 12. So I get a value of this. I'll just copy it right now to now put in kg for the weight of this value. So this is the weight. Will when anybody go and buy for this reinforcement in from the steel industry or from the steel market, they will ask you how many kg do you want for diameter 12 reinforcement. So you just say, give me 41651 kg, 416.52 kg. So like I said, I like to leave this thing in this map place. So since these two cannot approximate, just to not have any lacking in my quantity, I'll just put 6. It is better to have a slight increase than to have a decrease. Okay, so right now, I'll now go again right now to diameter what? 10 right now. Diameter 10 is only, so I'll change this back first to red, back to red, and then back to red. So I can now go right now, and then the 10 right now is only found one. As you can see, it's only one number from all things we are done here. So naturally only found one. So we can now go right now and then put this as blue, and also this again as blue to know the one we're doing now right now. So we will now have, since this is only found one, we will have one. So I have to now convert this right now to millimeter to meter. Okay, so right now we have to now impute that value, this value right now. 124,800, 124,800 divided by 1,000, which is converting this millimeter right now to meters. You can see the meters. So if we do equals right now, we have this. So copy this right now, onto this place right now, and paste it here. And since I like leaving it into this place, so I'll just add 0 to it. And also this one adds 0 to this one right now. This one was only 10, add 0 to this one. Okay, so right now we now have to now multiply this right now to now get in kg. in kg, which is the gram weight, which is the kg weight. So I have to now do this right now multiply by this unit weight of diameter 10, which is 0.64 0.62. So multiply it by 0.62, which is the unit weight for diameter 10. So multiply equals to that gives me this value. I'll just copy it right now and then go here right now and paste it in kg. So this is the total weight for diameter 10 for this entire project. So I'll now approximate it to one decimal place. So I'll just put zero point 0.4. Okay, so right now we have come to the end of this tutorial for today for Babin schedule. So right now, I'll just go again right now and just say match properties and just change all this back to white because we are done for today. So this is trying to cause an issue. So let me just, since they are the same, just copy this right now and put this here back and then remove this. Trying to cause an issue. Want to change color. Okay, so right now, this is how to perform your bar bending schedule fully. You can see how I took you. Let me now delete all these ones because I'm almost done. I'm done. So you can see how we started from the column starter bar all the way down. We did for the column stirrups. We did for the pad footing. We did for the plant beam. We also did to the summary. So you can see how we also did our shapes, everything. Now this is how to calculate fully your bar bending schedule. How to perform your bar bending schedule for any kind of project. So with the help of this Stonebridge template, using this same video, which I have done using this template, you can perfectly produce your bar bending schedule, as you can see it here. And also this is a Stonebridge company template that was designed automatically to perform a structural drawing for you perfectly. So if you have not gotten this template, I would say you should click on the link down below and download this template. It is not for free, it is just $5. But if you can afford this money, I'll say that it will reduce your workload to at least 80%. The time you would have spent in performing structural design, but with this template, it will reduce to at least 80%. So I'll say our advice that you get this template if you can afford it, $5. But if you can too, just use the step which I have already done for this video, and then just follow on to what you can do right now. Okay, so right now we have come to the end of this video for today. If you have not subscribed, I'll say please click on the subscribe button and make us to grow very fast. Click on the subscribe button and also share this video to your friends and call on your friends to come and watch our video, and also follow our channel Ekidel, and also subscribe to our channel. And also we are also on Facebook, and we are also on Facebook at Ekidel, also on Instagram at Ekidel, and also on Twitter at Ekidel. And also if you check on our channel, we also have a new channel which we are about to teach you guys how to um, how to program with Excel, on how to program bar bending schedule with Excel, where it will give you automatically. So we also teach you AutoCAD there, how to use shortcut in AutoCAD. So I would say you should follow that channel, because in the nearest time we will be teaching on that channel. That is Prota Code. That is that channel name is called ProCode. So thank you for your subscription and to the end of this video. So I'll say thank you and God bless you to the end of this video. So thank you, and then watch out for the next.